All right, hello. Today we're going to take a look at the idea of area versus average value, and also area versus total area. So consider the curve f of x equals x squared minus 1. I can ask GeoGebra to graph that for me, which I have here. And I want to consider it from 0 to 3. So let's draw a line at x equals 3. If I were to go about finding the area of this right now, what I would see is I would have a chunk of negative area because the heights of rectangles down here are negative. And then I would have some positives. So some of the area over here would cancel out some of the area over there. If I want total area generally means there is space between the line y equals 0, aka the x-axis, and my parabola here. And so there is an area in there. But if I were just to integrate straight across this function, I would get some negative area and some positive area, hence some cancellation, not the total area. Different thing. If I wanted to find the average value of the function in this region, I do need to consider that the y value is negative here and positive there. And so that those will interact together in a correct manner. So sometimes we need to break things up depending on whether the function is positive or negative. Other times we don't need to break it up. So I'll just do two different examples of this. So if I needed to find the total area, important phrase there, between this function and the x-axis, then according to the graph, I'm going to have to break it up based on that intersection point. And so before I can do this, I'll have to say, okay, where does f of x equal 0? So solving that, I'm going to have 2x minus 1, 2x squared minus 1 equals 0. That's going to lead to x squared equals a half. So x is going to be equal to plus or minus the square root of 1/2, which could be written a lot of different ways depending on how you like it. I'm just going to leave it like that. That's okay. And so that's this point right over here. So I'm just going to graph that. So in GeoGebra, since this is called f, to do a point, I start with parentheses and say I want the point SQRT of 1/2. Just extra parentheses in there, comma f of square root of 1/2. That looks all right. And I should do that point B down there. So that's where I want to split things up, at that point B. So my integral has to be broken into two chunks. Now, keep in mind, when I do attempt to integrate from 0 to the square root of 1/2, my function, 2x squared minus 1, I'm going to get a negative answer because the heights there are negative, right? So ultimately, whenever we're finding total area, we need to consider the absolute value of the function, right? Oops, wrong picture. There we go, sorry about that. So again, total area is what I'm looking for to consider the absolute value of the function, right? Just double check by calculating that. So you'll see we'll come up with a negative answer for just that chunk. All right, so let's see, I need an antiderivative. So antiderivative for x squared is x cubed over 3. So that's going to be a 2x cubed over 3. Antiderivative of 1 is just x. And I don't have to worry about the plus c here because this is evaluated definite integral, and I want to evaluate that from 0 to the square root of 1/2. And so cleaning that up, I have to plug in the square root of 1/2 first, and so that's going to give me 2 times the square root of 1/2 cubed over 3 minus the square root of 1/2. And so I'm going to ask a calculator to help me with that. Although it could be cleaned up a little algebraically, it's not going to do me any good. All right, so we've got 2 times the SQRT of 1/2, and that needs to be raised to the 3rd power and then divided by 3. And then we want to take away from that the square root of 1/2, which I think is like 7-ish. So I should get a negative answer. And there it is. So the area there seems to be negative, which makes sense because the x-axis is above, the function is below. So I'm getting approximately, and this is the exact answer to some version of what I have to the left over here. There, okay. So negative 0.4-ish. That was the ish part again. 47. Oh. Oops. Lost my stylus. There we go. All right. Double checking with GeoGebra, which does definite integrals. And I can see GeoGebra, please integrate. 3rd option. The function f tab from 0 to the SQRT of 1/2. And enter. GeoGebra says, yeah, it's about negative 0.47. Notice it's shaded in down here. And we could ask GeoGebra for more decimals if we liked, under options and then rounding, and we could say, hey, give us 15 decimal places, please. A little excessive, but what the hell. All right, so that is definitely negative. So if I'm looking for total area, I would want the positive version of that number. Right? And then I can go for the rest of it here, which is relatively straightforward since I have an antiderivative. So I would also want to integrate from the square root of 1/2 all the way up to 3 for 2x squared minus 1. And so that same antiderivative, 2x cubed over 3 minus x, but this time I'm evaluating from the square root of 1/2 all the way up to 3. And so we have a similar process that comes along here. We're going to get 3 cubed over 3, which is what, 2 times 9, which is 18. First part, minus 3. Let's put that in my head. 18 minus 3 is 15 on a good day. So that's the right-hand endpoint minus the left-hand endpoint. Let's see. Hey, you know what? We calculated that left-hand endpoint above, which is kind of cool. What's that crazy stuff up there? That's going to give me 2 square roots of 1/2 cubed over 3 minus the square root of 1/2. And we know that's a negative number, right? So altogether, the total area, let's Google. All right, so this number here, so I'm going to have 15 minus that number. And then, copy that. I want to add on the opposite of that number. Putting that all together, the total area seems to be about 14.53-ish altogether. Now that's adding both together. So on my notes over here, there we go. Highlighter, let's go green. I'm taking the positive version of this number, adding it to this number right here. And those two combined are what I believe to be, where'd you go? Too many screens here. Ah, there we go. About 14.52. So just double checking in GeoGebra, if I also find the integral option of f from the SQRT 1/2 to 3, separate those so they're not overlapping. That's A. Okay, so B is 15.47. So if we add another 0.47 on top of that, that should give me what I calculated over here. Oh shit, I went the wrong way. I got an error somewhere. 15 minus that, all right, plus the opposite of that. Signers, so it should be 16 point something. How do I get, type something on here? Let's get back to the notes here. Let's see, twice the square root of 1/2. I guess the same thing we have up here. Wait a minute, what happens? Okay, well, let's just back off on the calculator. Take this chunk out. 15 minus that number. Oh, that's interesting. It's a different number than what GeoGebra has. Did I type something wrong in GeoGebra? I don't think so. Interesting. Square root of 1/2, 0 to 3. Okay, that is negative. And then if I integrate from, so let's just hide you for a moment. Square root of 1/2 onto 3. That should be 15.47. That makes sense. Because we've got 15 minus that negative 0.47. All right, so what did I type wrong in the calculator over here? 15 minus twice the square root. Blow that up a little so you can see it. Oh, do I have parentheses out of place here? I do have parentheses out of place. There should be a parenthesis around this little sucker right there. Ah, and that should be 15.7. Okay. Good thing we double check our work, huh? And learn how to use a calculator properly. So then, so that is the second integral. Copy that sucker. And then I want to add on the opposite of the first integral. And then I should get 16, oh, 15.9-ish. Yeah, that's right. 0.47 plus 0.47 would be 0.94. Ooh, all right. And so now GeoGebra is calling this little a and little b, so I could just say, hey, GeoGebra, what is a plus b? And GeoGebra will say, oh, I want a plus negative b. Type. And there's my 15.94. Well, that was exciting, wasn't it? All right. So again, total area is what this one was all about. I'll come back with one more application soon. Bye-bye.